Vijay Kumari Madam, one of the senior faculty of our department, Computer Science Engineering Department, Bonu Venkatachalma Institute of Technology and Science. Request to introduce the second session resource person, Dr. KVD Kiran sir. Vijay Kumari Madam, are you there?
Yes, sir. I'm there. Good evening, everyone. This is Vijay Kumari representing the Department of CSC, BVC ITS. It gives me an immense pleasure to present you the profile of our resource person, Dr. KVD Kiran Garu. Dr. KVD Kiran sir is an accomplished academician and researcher with over 19 years of experience in teaching, research, and academic leadership. Currently, sir is serving as Deputy HOD of CSC and professor at KL University, and he significantly contributed to the curriculum development, research initiatives, and faculty mentoring. His expertise span software engineering, cybersecurity, wireless network, and machine learning, with a strong focus on risk assessment, cloud security, and DevOps. From Acharya Nagarjuna University, Dr. KVD Kiran sir received his doctorate degree in CSE and completed MTech, MSc, as well as BSc from the same university. Earlier, sir also worked as Associate Dean, Academics in OBE Division and Placements at KL University. Sir has published more than 65 international journal papers, which includes Scopus, Web of Science, IEEE, Springer, elsewhere, and also published 2 textbooks on cybersecurity and research methodology. His research areas includes cybersecurity and risk management, machine learning in cyber threats, wireless sensor networks, and IoT security. Under his guidance, 7 research scholars were awarded PhD and 5 scholars were currently being guided. Dr. KVD Kiran sir received a Best Academician Award in the year 2023, a Significant Contribution Award from CSI, Research and Development Leadership Award from AI Medical Engineering Society, IBM Drona Award for guiding TGMC project, and Best Teacher Award multiple times from KL University. Sir is a life member in CSI, IAENG, IAECS, and ACM, and also reviewer and editorial board member of IEEE, Springer, elsewhere, IJREST, and AI research journals. We are very glad to have such an eminent personality for today's session. I cordially invite Dr. KVD Kiran sir to this faculty development program. Welcome you, sir.
Thank you, Vijay Kumari madam. Thank you for a very good introduction about me.
Thank you, sir. Thank you, sir. And one more thing is,
Can I share the screen?
Share, sir. Share, sir. Meanwhile, I am informing all the attendees, all the participants. Kiran sir is my supervisor for my PhD in KL University. Under his supervision only, I am able to complete my doctoral degree on thyroid disease analysis. I'm very much proud to feel as a supervisor, Dr. KVD Kiran sir is very supporting for the scholars, and yeah, one of the key persons for materializing this workshop into this realization from application part to now implementation point. The role of Kiran sir is very who's is there. But sir, thank you, sir. Thank you very much, and please continue your session, sir.
Thank you, sir. Thank you. Thank you, Srinivas garu. Is my screen is visible and shared, sir?
Visible, sir.
Okay. I request everyone, please mute yourself. Okay, thank you. Let us start the session. GPU programming, high performance computing using AI. In this presentation, I am going to present the introduction of GPU computing and programming, the history of GPU programming, when it has been started, how it has been started, what are the key milestones that are present in the GPU. Then we are going to see how we are going to map the GPU programming to high performance computing. The mapping, how it is going to be done, what features are going to be present, what are the key features that are going to be present, and what do you mean by parallel processing in GPU computing or GPU programming? What is the architecture that is present in GPU programming? Different types of layers, components that are going to be present. Applications of GPUs. The challenges in the GPUs. Optimization techniques. Benefits of GPU. And the important aspects of GPU parallel programming patterns with real-time applications. And finally, after the conclusion, we are going to see in which areas at present GPU programming, where we are going to have the case studies and the problem statements for doing the PhD, for pursuing the PhD, which is going to be helpful those who are interested. So it is about the key concepts that are going to be present by me in the concept of GPU programming, high performance computing using AI. So dear participants, this presentation mainly delves into the world of GPU programming, exploring the power of the specialized process for high performance computing and AI applications, and also different types of programming patterns, architectures, applications, and the power of the technology that is going to be performed by GPU programming. So now let's start the introduction to GPU computing. Basically, GPU stands for Graphics Processing Unit. Graphics Processing Unit. It is one of the computing which is used for specialized process, initially developed for rendering the graphics and also used for performing parallel processing tasks. So it is one of the highly revolutionized high performance computing, which enables the fundamental concepts, benefits, and architectures of the GPU, which makes it transform faster, more efficient data processing across a wide range of applications. In the history of GPU programming or the computing, generally when we are going to study, first we need to know what it is. So here it is one of the computing technology where we are going to develop different types of graphics applications and also perform different types of parallel processing tasks. The task which we are going to perform, it is going to be done parallelly. How it is going to be done, we will see in the coming slides. So before that one, let us see the history of GPU programming. Origin, when it has been started. Basically, in 1980s and 1990s, graphics mainly focused on the GPUs. The early GPUs, that is graphics processing units, were designed to accelerate the process of generating an image or the process of generating a video from a 3D model or from other input data. So that for graphical applications like video games with fixed function pipelines, optimized for tasks like rasterization, which we have studied in computer graphics for converting the vector images into pixel-based images, or having some shading concepts and having some texture mappings. All these have been introduced before GPUs. So here they are going to provide some graphics to the images, which is going to show as a rasterization or having some renderization, rendering the graphics of an image or the texture mapping. So in the GPU, for every book or every subject, we are having some standards, some book that is going to be present, which is called as a Bible. So similarly, here for GPU programming, we are having one unit called as NVIDIA. It is a NVIDIA. It has been introduced a graphics processing machine, first graphics processing machine, which is called as GeForce. GeForce. So GeForce 256. So it is the thing that has been present here. It is the first world graphics processing unit with a hardware transformation engine. So here, what it is going to do is, it is one of the NVIDIA, it is one of the US-based multinational corporation, basically. What it is going to do is that it is specialized in artificial intelligence and artificial computing, accelerated computing. So they are going to design and manufacture graphics processing units, application programming interfaces, and system on a chip units. It is the main purpose of NVIDIA. So here we are going to have the graphics processing unit, parallel computing, GPU architecture. We are now in GPUs. GPU stands for graphics processing unit. Here, for that, we are having one multinational corporation called as NVIDIA. It has been introduced one graphics processing unit called as GeForce 256, and it is used for artificial intelligence and accelerating computing. So generally, when we are going to perform the graphics, earlier we are going to use the different types of programming interfaces like OpenGL, Open Graphics Language, DirectX, provided the application programming interfaces for performing parallel computing. So here, when we are going to say parallel means simultaneously. So when we want to do the task simultaneously, what we need to do is, a large task is going to be present. It is going to be divided into small units, and each unit is going to be given to a one particular machine, so that all those are going to be done parallelly at a time. Means breaking down a complex task into smaller independent units, so that it is going to be given to the multiple cores for performing the task simultaneously. So in the year 2000, that concept, it is called as general purpose graphics processing unit programming has been introduced. So here we have been slowly transformed from fixed functionality pipelines to programmable pipelines. It is called as GPU. So generally, the applications which are going to be present for GPU in terms of parallel programming is, it is going to be used in physics simulations, matrix calculations, scientific computings. In addition to that one, in year slowly we move from 1990 to 2000, 2002, now we are moving to 2006. Now we have been come across with a revolution by having an architecture. In that we are having, that architecture is called as CUDA, C-U-D-A, and Programmable Computing Revolution. CUDA stands for NVIDIA has been launched that architecture. That architecture is, C stands for compute, U stands for unified, D stands for device, A stands for architecture. Compute Unified Device Architecture. The first architecture which enables the programming GPU for general purpose tasks using different languages. So here in this architecture, CUDA architecture, we are going to perform massive parallel operations, large operations, thousands of cores are going to be used, simultaneously many types of operations. Hello?
Participants, please mute your audio.
Is the voice is okay, sir? Any problem?
Yes, sir. Okay, sir. Okay, sir. No problem.
So now we move to the 2010, where we are going to have the OpenCL and other frameworks. OpenCL stands for Open Computing Language, which have been introduced as an open standard for cross-platform GPU programming. So here we are going to use the frameworks like OpenACC. It is one of the framework which is going to be used with performing the parallel programming, parallel processing by using GPU in HPC. So for that, we are going to have the parallel processing, the specialized hardware which is used for computing purpose, and the computations which are going to be used and make it is going to be done. So till now, we are going to see what do you mean by the introduction of GPU computing, the history of GPU computing, the challenges that are going to be present in the GPU computing, the key process, the key features that are going to be present in the GPU computing. So before that one, the benefits, why we are going, when we are going to study a topic, they should have some benefits. The advantages are, first one, we have seen parallel processing. A huge amount of task data is going to be processed within a less amount of time by using some supercomputers, high performance computers. So in the GPU computing, the performance is very good, energy efficiency is very high, the scalability is up to the mark. When we are going to have the increased performance in terms of parallel processing, what we are going to do is we are going to divide the task into smaller units for simultaneous execution by thousands of cores. Cores are nothing but the CPUs which are going to be present for processing it, making them ideal for data intensive application like machine learning. So here, so that performance is going to be increased compared to the traditional based systems. Next, GPUs are designed to be more power efficient, reducing energy consumptions and operating cost. The cost has to be reduced, then we can use it. If the cost is going to be increased, nobody will prefer for that one. So energy efficiency in terms of cost is going to be reduced. The scalability. GPU clusters, a group of systems, can be easily scaled to handle larger workloads and meet growing computational demands. So now the GPU hardware architecture which is going to be present. Whenever we are going to talk about an architecture or a framework, we are having a layers concepts which are going to be dependent on one another. So the multiprocessors, the hierarchy, the connectivity of the devices are going to be present. So here, when we are going to use the architecture points in terms of hardware, we are going to have a GPUs, the graphics processing units, where we are going to have multiprocessors and memory hierarchies which are going to be optimized for performing the parallel computations. This is what the architecture of GPU says. What it is going to do, it is going to have multiprocessors and memory hierarchies which is going to stream the data optimized for performing parallel computations. This is why the GPU architecture is going to be used. When we are going to talk about those multiprocessors, what are the advantages? The speed. So faster computation power is going to be obtained. Compared to CPU, it is thousands of simultaneous operations are going to be executed by GPU. It is the multiprocess concept. The memory which is going to be used, the massive parallelism of the architecture that is going to be performed, and optimized architectures reduce power consumptions. And the scalability and the interconnectivity that is used to transfer the data between the GPUs and other components, so that multiple GPUs can handle larger data sets, meeting the high performance computing demands. So for that, in this, we are having GPU programming models. Just now we have seen the architecture, CUDA architecture, by using OpenCL, OpenACC, DirectX computations. All these NVI DIA, it is one of the proprietary programming model, the CUDA, which we have seen. Can anybody let me know in the chat box what is the full form of CUDA? Can anybody please type in the chat box? Full form of CUDA. C stands for compute, U stands for unified, D stands for device. As we are studying about architectures, A stands for architecture. Like that, we have seen different types of architectures, and OpenCL, it is one of the language which is going to be standard for the cross-platform, performing the parallel programming on heterogeneous systems, which we have seen. And OpenACC, it is a directive-based programming model that simplifies GPU acceleration for existing code. And DirectX Direct Compute, it is one of the programming interface primarily which is used for gaming and graphics applications. So dear participants, here we have seen different architectures. Which architecture is going to be suitable for which purpose they have been mentioned. By using those concerned languages, we are going to use it and we are going to move on. So in that, we can use different types of languages for performing all these operations, to have energy efficiency, to have the scalability, to have faster computation, and to perform simultaneously, handle the thousands of simultaneous operations. For all that, we can use different programming languages like C, C++, traditional languages, which are used for GPU programming, often through CUDA or OpenCL. And Python increasing popular for GPU accelerated computing with libraries like TensorFlow or Python.
Hello, sir.
Is it audible? Sorry for the...
No, it is audible, sir. No, it is audible, sir.
So these are different types of programming languages which are going to be used in the GPU. So dear participants, till now we have seen what is GPU computing, what is GPU, the history of GPU programming, what are the milestones and the key challenges of the GPU, and what are the different types of architectures that are going to be present, we have seen, and what are the different types of programming languages which are going to be present. Till now, basics have been completed. Now, to move to the computing applications, now let us see, our topic is GPU and HPC. For that, how we are going to map GPU programming to high performance computing, we need to know. For that, why GPUs are going to be suited for high performance computing. The first more reason is that with the help of GPUs and high performance computing, we are going to have the massive parallelism operations. Parallelly, we are going to have thousands of smaller cores optimized for parallel processing. Compared to CPU with general purpose cores, here we are going to use the optimized smaller cores which are going to be used in the GPU for performing parallel processing. It is one of the reasons why we are going to have the GPU programming to high performance computing. When we are going to link that GPUs to the HPCs, we are going to achieve massive parallelism. Massive parallelism means all the tasks are going to be done simultaneously without any problem. High memory bandwidth is going to be obtained. So GPUs have high bandwidth memory, enabling fast access to large data sets, as well as they are going to be used in weather modeling, molecular dynamics, computational fluid dynamics. All these concepts are going to be help us for having in the development of the rocket booster technology. So it is one of the technology which is going to be used for GPU programming to map to the high performance computing. And in the year 2008, the first petascale supercomputer, here at present, we are having different types of supercomputers in India. One of the supercomputer is Param, P-A-R-A-M. The metrics which is going to be used for the Param, metrics are the measurements. It is nothing but the flops, floating point operations per second. It is the metric that we are going to be used for that one. When we are going to use meta, mflops, gigaflops, megaflops, petaflops, like that, we are having as the size of the data, the speeding is going to be increased, the data processing is going to be increased. More amount of data is going to be done parallelly. Executed is going to be done parallelly. So the supercomputer, which is called as Roadrunner, R-O-A-D-R-U-N-N-E-R. It is the first petascale supercomputer which has been introduced in the year 2008 for mapping the GPU programming to high performance computing. It is called as the Roadrunner, which is going to use GPUs DGX series and GPU accelerated clusters, which is going to be helpful in climate modeling, scientific research purpose, and genomics. In these areas, it is going to be used. So the key features that are going to be present are thousands of cores for parallel processing, ability to offload the computational task from CPU. CPU are going to be Excel and highly parallel computations are going to be performed. Scientific computing, it is going to be help in the molecular modeling, climate simulations, fluid dynamics. It is going to be used in video games, real-time graphics, rendering, and physics simulations in modern video games rarely help on GPU processing power. When we are going to use all these, we need to know the challenges and the limitations of the GPU also. Why? Because what are the disadvantages that are going to be present, that if you know it, based on that, we can modify it according to our needs so that it will be helpful for the society. For that, what are the challenges and limitations of the GPU computing that is present? Let us see now. The programming complexity. What is the programming complexity that is present? The memory management, the limited generality. These are the main three disadvantages that are going to be present in terms of the limitations of GPU computing. So whenever we are going to say the programming complexity, complexity is the thing that which we are going to verify in terms of time complexity or the space complexity. Time complexity, the amount of duration which the program is going to be executed in terms of time, it is called time complexity. It is generally, it is going to be measured in terms of three ways. Big O notation, like that we are having some big O, theta, omega, like that we are having. That is the programming complexity, which we are going to ensure that the accelerating applications require specialized programming skills so that it is going to be executed within less amount of time. Memory management, it is one of the crucial things which we are going to be think of it. Whenever we are going to use memory management, that effective utilization of the memory has to be done, as well as within that availability memory, we need to be utilized carefully so that the data transfer between the CPU and GPU is also a critical challenge in the memory management. The limited and generality. GPUs are optimized for specific workloads, so they may not always be the best choice for general purpose computing tasks. So, dear participants, let us see the advantages of GPU over CPU for parallel processing. So, till now we have seen the basic things and the architectures. Now, let us see the comparison between GPU and CPU. How it is going to be done, where it is going to be done. So we have already seen there are three advantages compared to CPU: providing higher parallelism, providing increased memory bandwidth, and energy efficiency, which we have already seen and make it so effectively. So now in the architectures which are going to be present, there are different architectures which we have seen. The first architecture which we are going to see is CUDA. The architecture, it is one of the NVIDIA parallel computing platform and programming model designed for GPUs. The kernel functions, whenever we are going to say the architecture, what are the core components that are going to be present, we need to know, and how it is going to work. When we are going to check it out, the core components, the kernel functions, the thread hierarchy, the memory management, how the kernel, the executed part of the GPU cores performing parallel operations on data, we need to know it. And the thread hierarchy, how the organization of the threads have been organized in blocks and grids so that efficient management of parallel tasks are going to be happened without any disturbances, without any segmentation, without any thrashing that is going to be present. Memory management, understanding different memory spaces and how to effectively transfer the data between the CPU and GPU. All this is one of the things that are going to be present. When we are talking about the core components, the streaming multiprocessors which are going to be used, the primary units which are going to be present. In that which we are going to have, this is different types of architectures that are going to be check it out. So streaming processes, the primary units responsible for executing parallel threads. So we are going to execute data parallelism. We are going to have the task parallelism. We are going to have the synchronization. So for that, the primary units are responsible for executing the parallel threads. And there are two types of memory hierarchies, basically, as we have seen just now, memory hierarchies. Those are the thing that which we have seen, the memory management, global memory and shared memory. Global memory, which is accessible to all the threads, but it is very slow. Shared memory, high-speed memory shared within a thread block. For a particular thread, it is going to be shared and it is going to be used. Once it has been done, it is going to be given to the another processor. So that the registers, which are very small, fast memory for individual threads. So in the memory hierarchy, we are having global memory, shared memory, registers. Registers are very small, fast memory for individual threads. Shared memory, they are high speed memory, but compared to registers, they are somewhat, the speed is less, and which is going to be shared within a thread block. And the global memory, which is going to be accessible to all the threads, but it is very slower. So the data parallelism, applying the same operation to multiple data elements simultaneously, dividing the large task into smaller subtasks that can be processed independently, and coordinating the execution of threads to ensure correct data dependencies and prevent the race conditions. That is the synchronization. So the thread block pragmatics, the synchronization that is going to be happen, all that is going to be obtained in single instruction, multiple data performance. So deep learning on GPUs, it is one of the latest technique which is going to be used in the neural network training processes and GPU accelerations. So for that, we are going to know different types of optimization techniques that are going to be present. When we are talking about the optimization techniques, the techniques which we are going to use are memory coalescing, shared memory utilization, thread block synchronization. These are the three techniques which are going to be present. As the first one, the memory coalescing, it is nothing but it is going to align the memory access patterns to reduce the latency. The amount of waiting time is going to be reduced. Optimizing memory access patterns to reduce memory latency. It is how we are going to align the patterns in the memory so that the latency is going to be reduced. It is memory coalescing. The shared memory utilization. Here, what it is going to done is, in one sentence, we can say that it is going to employ fast data on chip memory, so that within less amount of time, we are going to have more amount of data is going to be transferred. So using fast on chip memory for data sharing between the threads within a block, which is going to be provided in the shared memory utilization. And the third technique which is going to be used for optimization is thread block synchronization. We are having an operating system, different types of synchronization techniques. The same thing, which is nothing but a unit of code within a block, is going to be executed in a synchronized manner, preventing the data race conditions. So it is another thing which we need to remember in optimization techniques. So we are having different types of GPU optimization techniques. Among them, one of the technique is FE/FI optimization technique, which has been present here. It is one of the technique architecture which is going to be shared here. So the GPU optimization techniques, what it is going to show is mainly it concentrates on different techniques like memory parameters like memory coalescing, shared memory utilization, thread synchronization, kernel fusion, which combines operations to reduce overhead in the kernel execution, so that it is going to have fully potential of your GPU accelerated applications, explore the architecture, identify the bottlenecks, and implement the strategy for optimal performance. When we can show the optimal performance is if you know the disadvantage in that one and how we are going to remove it and how we are going to compare with the latest technologies and show that our technique is the best. So for that, you need to know all these basic things. Then only we can have the technique of optimization, which is going to be helpful in the concept of those issues. So now when we are going to have different types of GPUs and their roles in modern computing, we need to know the programming models which are going to be used for GPU computing. As we have seen different languages which are going to be used as C, C++, Python, Rust, all that we have seen. And also we have seen different types of models like CUDA, OpenCL, OpenACC, which are going to be helpful for the integration of GPU acceleration into existing code databases, coding bases, or heterogeneous systems for using widely used in artificial intelligence and scientific computing. All these are going to be introduced in the GPU in the modern computing. When we are going to have the benefits, so the performance is going to be increased, where faster processing than CPUs, and energy efficiency is going to be done, optimized for parallel workloads, reducing power consumption. Scalability, easily scaled to multiple GPU clusters for handling larger workloads. So here key parallel programming patterns are going to be used. Data parallelism, which is going to divide the data into smaller chunks, smaller parts for performing, for doing simultaneous processing. Thread-based parallelism, where we are using multiple threads on each GPU core. Kernel design, defining the computational performed by each thread. Memory optimization, managing data transfers between GPU and CPU efficiently, and having optimization how data is read from memory to minimize the access latency. All these we have seen for having the utilization of the large number of cores on a GPU for high performance computing. When we are going to see all these, there are different important aspects which are going to be present of GPU parallel processing patterns, which are going to be helpful. So the parallel processing, specialized hardware, hardware acceleration, enabling new frontiers. So when we are going to talk all this, we have seen multiprocessors, memory subsystems, interconnects, where we have seen the concepts of data parallelism, where breaking down of large data set into smaller data set for processing multiple threads, and also the operations that can be applied to each data element without having significant dependencies. Here, dependencies are also crucial role when we are having data parallelism, where the real-time examples are used for vector addition, image processing, matrix multiplication. These are the examples which comes under for data parallelism. Whereas thread-based parallelism, here the second thing which we have seen is the thread-based parallelism. When we are going to check it out, utilizing multiple threads on each GPU core to execute computational simultaneously. So here multiple threads on the GPU are executed simultaneously. Each thread performs the same operation on a different data element. Requires careful management of thread blocks to optimize workload distribution. It is another thing which we have seen in the hardware acceleration and the specialized hardware, where we are going to concentrate on the kernel. Kernel is a operating system of the function which is launched on the GPU or the CPU that defines the computational process on the thread, where we are going to have minimized execution overhead, balancing the overhead, optimized memory access patterns, and which helps us in having in different fields like deep learning, scientific visualization, and so on, which are going to be used in computational intensive technologies. So when we are going to understand GPU architecture and the core components, which we need to think of it is the stream multiprocessors, where all building blocks of GPUs are responsible for performing parallel processing, and memory subsystem, the optimized memory hierarchy is going to be included, and shared local memory enables high bandwidth data access. Interconnects, efficient on chip communication and data transfer between multiprocessor and memory subsystems. So what we are going to see here is the memory optimization is going to be happen, utilizing GPU memory efficiently to avoid the bottlenecks. So for that, we are going to have different techniques like zero copy data transfer, pinned memory data transfer, collapsed memory access data transfer. All these are different types of arranging data in memory so that the global shared local memories enables the bandwidth data access. For that, we need to have the identification of performance, the bottlenecks in accelerating of the applications. When we are going to have all these features, we are saying that we are going to perform parallelism, we are going to have memory optimization is going to be done, interconnectivity is going to be happen properly. For that, while doing those, we come across some bottlenecks, we come across some problems. What are those problems that are going to be present? The first one is profiling. What do you mean by profiling? What are the different types of optimization strategies, and what are different types of bottleneck analysis that are going to be present? When we are talking about the profiling, what we are going to do is we are going to use some specialized tools like the Rust or whatever it may be, and analyze the performance of the GPUs along with the code that has been accelerated. So how it is going to be done, what are the problems that are going to be present, what are the tools which are going to be used, all three has to be mapped properly. And optimization strategies, we have seen different types of optimization strategies. We need to develop and implement one optimization technique which address the identified performance bottlenecks which have been done in the profiling. In between, we are having the bottleneck analysis. Analysis is one of the crucial thing. Profiling and optimization techniques are one thing, and analysis of the bottlenecks which are going to be done is another thing. So it is one of the crucial thing where we are going to have the research in the bottleneck analysis and optimization strategies of the GPUs. So bottleneck analysis, where we are going to examine the graphics processing units resource utilization, memory access patterns, how the memory is going to be stored and how it is going to be retrieved, and how the data transfer is going to be happen, and how the kernel execution is going to be happen. Different types of kernel architectures we have studied. Those are different types which we have seen are the collapsed memory access, zero copy data, like that we have seen. So those bottlenecks, limiting factors are going to be identified. So the memory strategies for GPU optimization, just now we have seen memory collapsing, it is one of the technique. Data placement, what we are seeing is these bottleneck analysis we are going to perform here for having the optimization techniques, so that it is going to, GPU is going to have parallelism tasks which are going to be helpful. So when we are going to talk about the memory management strategies for GPU optimization, memory collapsing, one of the technique which is going to be done, where data structures and access patterns are going to be helpful for maximizing the memory bandwidth and minimizing the latency. Data placement, it is one of the strategy which is going to allocate the data structure to have the leverage of the GPU's memory hierarchy. Asynchronous transfers, overlap data transfers between CPU and GPU with kernel execution for improved efficiency. Asynchronous, synchronous transfers are going to be happen, where we are going to see the asynchronous data transfer, which is going to analyze the problem to find the parts that can be done either synchronously or asynchronously by processing the data independently. And the memory compression, employ the compression techniques to reduce memory footprint and bandwidth requirements. When we are going to perform all these, which we are going to see, the profile and benchmark is also plays a crucial role. When we are going to see the regular measure performance to identify the bottlenecks and optimize the code. So here, as far as the data that is going to be concerned, how it is going to be done, what is the impact that is going to be done. So when we are going to have all these memory management strategies for GPU optimization, as I mentioned here, the bottlenecks in the GPU accelerated applications, the bottlenecks that are going to be present, it has to be analyzed. For analyzing, we are having different types of constraints, the impacts on this. For example, we are having different laws which we have studied. One of the important law which we have studied is the Moore's law, which predicts the doubling of transistors in chips, which is slowing down while GPU continues to improve. So it is one of the law which is going to be present for memory management optimization strategy. The number of applications accelerated by the GPU has increased significantly with a 22-fold rise in developers using GPU programs. So CUDA is one of the centralized architecture computing applications, including deep learning and simulation tools, which improves the memory management. So the limitations that are available in the GPU memory and the computing power when designing the algorithms is one of the crucial factor which we need to remember. So for that, we need to have the leveraging parallel processing and thread level parallelism. So for that, how the thread hierarchy is going to be done, what are the work distributions are going to be done, how the synchronization is going to be happen. The performance of GPU, which is going to have accelerated applications, has shown dramatic improvements exemplified by the performance increase of GoogleNet over 3 years. So here, as the number of years have been increased, the application capacity, accelerating application capacity has been improved a lot. The organization of grids, logs, and threads have been used to maximize the parallel execution. Once it has been done, how the partition of the work and to which partition the task has to be assigned so that the GPU resources are available without having any task to be stopped. And managing the thread synchronization and computing to avoid the race conditions and having the highest performance, the maximum efficiency. For that, we are going to have instructional level optimization, memory optimization, occupancy optimization, register optimization. Whereas instructional level optimization, it is one of the reduced branch divergence technique and improve instruction level parallelism with GPU kernels, where GPU memory hierarchy and implementation effective memory access patterns by memory optimization, maximize GPU occupancy by adjusting the thread block size and resource utilization, register optimization, which minimize the register usage and spilling to improve overall kernel performance. So these are some of the things which are going to be done. Now the important part, till now we have seen only the basics. Now where it is going to be used, what are the real-time applications, all that we are going to see now, dear participants. That is the applications of GPU computing. If any of the participants are having any doubts, please free to type it in the chat box. Any doubts? Okay. Now, before going to the case studies and the applications of GPU computing, first, as we have seen the high performance computing, all that we have seen. So directly, if you go into that depth knowledge, it is very difficult to understand the real-time application. So for that, the first thing, it is going to be used in machine learning and artificial intelligence. It is one of the important thing which you need to remember. The GPU computing for mapping to the high performance computing, it is going to be helpful. The applications are machine learning and artificial intelligence, and accelerating the training and inference for deep neural networks. It is another concept where it is going to be used. And frameworks like TensorFlow and PyTorch rely on GPU acceleration, scientific simulations, climate modeling, molecular dynamics, fluid dynamics, medical imaging, image segmentation, visualization, autonomous vehicles, real-time sensor data processing, gaming and visualization, VR, AR applications. These are some of the real-time applications which I have studied and I have noted down and of GPU computing. So when we are talking about the GPU computing, the programming complexity, the memory management, the generality, which are going to be the crucial challenges. So the application domain in which it is going to be used, what are the techniques that are going to be done, what are the performance gains that is going to be done. First, it is used in deep learning. The kernel fusion, memory coalescing, tensor core utilization, these are the optimization techniques. These are the name of the techniques which are going to be used. For what purpose? For having the speed up on the training and inference processing. Computational fluid dynamics, memory bandwidth optimization, shared memory usage, thread parallelism. These are the optimization techniques which have been used. And here, the amount of performance is 10 times of acceleration on the CFD simulations that are going to be present. The third one, video processing, kernel fusion, asynchronous data transfer, wrap level parallelisms. These are the optimization techniques which have been used, and it is improved real-time performance and reducing the latency. As I mentioned, they are going to be used in autonomous vehicles, medical imaging, scientific simulation, financial modeling. These are some of the things which we have seen. Autonomous vehicles means GPUs mainly power real-time object detection and decision making for self-driving cars. A separate PPT has been given for the autonomous vehicles. We will see medical imaging. So here, when we are going to talk about medical imaging, how it is going to be done, scientific simulation, please, I request, please mute yourself. Thank you. So scientific complex problems. GPUs are essential for tackling complex scientific problems that require massive computational power, such as climate simulations, climate modeling, protein structure analysis, analyzing the protein structure which can be reduced, and how it is going to be done by using the GPU architectures. Extensive time that all those scientific simulations is also going to be takes place. And financial modeling. GPUs accelerate complex financial calculations, enabling the faster risk assessment and portfolio optimization. So first one, the GPU rendering and visualization, which we have seen one of the first application, the graphics which is going to be used in data visualization, virtual reality, augmented reality, and photorealistic rendering. What do you mean by rendering? It is one of the feature which is going to be present, which is a process of generating an image or generating a video from a 3D model. It is called as a rendering. So when we are going to talk about it, GPU accelerating rendering engines, where it is going to be helpful for producing the extreme power, realistic and detailed 3D visuals, which advanced lighting, shading, and texture techniques such as architecture, product design, and visual effects are going to be obtained. It is the photorealistic rendering. Data visualization. The creation of highly interactive, responsible data visualization tools allows users to explore complex data sets and gain insights in real time through intuitive, visual, stunning interfaces. Virtual and augmented reality. So here the immense processing power of GPUs is essential for delivering the high quality, low latency experience for cutting edge virtual and augmented reality applications. All these, they are going to be used in genomics research, where indispensable of accelerating bioinformatics workflows from DNA sequence to gene expression analysis, allow research to uncover insights into the building blocks of life. Cryptography and security, where we are going to have the cryptanalysis, encryption and decryption, helping to secure critical systems and data. Like that, we are having scientific simulations, where we are going to see the complex scientific problems that require climate simulations, protein structure analysis, all those is going to be done. Financial modeling, where better informed decision and staying ahead of the competition. So GPUs in real-time video processing. So here it is one of the visual demonstration of CPUs that is going to be done. Sorry. Video encoding, video editing, live broadcasting. It is the real-time video processing which is going to be happen. So here we are going to have the demonstration, the difference that is going to be present, the memory management, the limited generality, the programming complexity which is going to be present are going to be studied in detail. GPUs are optimized where GPUs enable real-time AI applications. like image recognition, where we are going to have video encoding, video editing for image recognition, natural language processing, and having neural networks. Here, what we are going to do is we are going to have some AI models are going to be used, which is going to be done for massive matrix multiplications for video editing and video encoding and image processing for live broadcasting, and also other linear algebra operations which are going to be used in GPUs for designing and handling efficiently, so that we are having low latency and high resolution where the audience can experience the live events. And also we are going to have different types of CUDA libraries, such as deep neural network library, and different types of frameworks are going to be used for producing high quality video content with minimal latency. And also video editing softwares are going to be helpful for having the color grading and having visions to life. In addition to that one, it is also going to be used in medical imaging and diagnostics, where we are having three phases: image acquisition, image processing, visualization. Whereas in the previous slide in GPU real-time video processing, first video encoding, video editing, live broadcasting is going to be happen. Whereas here it is the medical imaging and diagnostic. It is one of the high performance computing which is going to be done. Image acquisition, how it is going to be done? Here, GPUs accelerate the complex mathematical calculations required for acquiring high quality medical images such as MRI, CT, PET scans, all that are going to be used for providing accuracy and patient outcomes. Based on that, image processing is going to be happen, where we are going to use some image processing algorithms for making the enhancement segmentation and also medical scanning, which allows the healthcare professionals to have the complete diagnosis and making the treatment decisions. Based on that, visualization is going to be happened. So the 3D visualizations or 2D visualization or 4D visualization of medical data, which helps the doctors or the clinicians better understanding the complex anatomical structures and plan the procedures more effectively. And the next one which we have studied, autonomous vehicles and robotics, where the parameters which we have used are computer vision, sensor fusion, motion planning, deep learning. Whereas computer vision, how it is going to be used? GPU, it excels at the real-time processing of sensor data from cameras, radar enabling autonomous vehicles, lidars, and robots to accurately pursue and understand their environments. It is one of the things which we are going to take it out. So for that, computer vision, it is one of the image classification, object detection, and autonomous vehicles concepts are going to be used. Based on that, sensor fusion is going to be the next parameter. Here, GPU accelerates sensor fusion algorithms, integrate the data from multiple sensors, allowing autonomous systems to make more informed decisions and navigate complex environments safely by using the NLP concepts, the language models like GPT, all that is going to be used. Based on that, motion planning is going to be implemented by using reinforcement learning. Applications in robotics and gaming are going to be used, which enables the autonomous vehicles and robots to rapidly evaluate the optimal paths, enabling the smooth and efficient navigation. The last one, deep learning, it is one of the stable diffusion and algorithms which are going to be used for the generative AI and enabling the autonomous systems to learn and make complex decisions from object detection to behavior detection. So dear participants, these are some of the main applications which are going to be present for having the mapping of GPUs to HPCs, which is why AI depends on GPUs, how the training of the learning models are going to be happen, all that we have seen. So based on that, we are having the hardware evaluation, the quantum computing, all that is going to be done. So in that, what is going to be happen is, from every application to application, what we have seen, continued innovation is going to be happen. From one architecture to another architecture, from one application to another application, we are having continuous innovation, which makes that application or that protocol or that algorithm or that architecture more powerful. It is one of the things which we need to remember, which makes the other or the protocol or the who is going to develop will further drive innovation across a wide range of industries. The next one, emerging applications. It is going to be used in different types of applications, from quantum computing to real-time holographic displays, which enables the groundbreaking of new applications that push the boundaries of what are possible. Democratization of GPU access, increased availability and accessibility of GPU resources through cloud computing and other platforms, which empower a wide range of users to harness the power of GPU technologies. So this is one thing which we need to remember, which makes the GPUs more attractive and more useful. So here, the future trends which are going to be present in GPU programming are, first one, hardware evaluation is going to be done. Means new architectures are going to be designed for every artificial intelligence by using AI and HPCs, and having emerging applications like quantum computing, real-time holography, and genomics. And democratization of access, just now we have seen the cloud platforms which are going to be provided like AWS, Google Cloud makes the GPU accessible for a wider audience. So dear participants, the democratization, emerging applications and innovations, these are the main things which makes the GPU more popular, which makes the GPU more useful for the users to work on it. So GPU computing, it is an revolutionized high performance computing, enabling the advancements in artificial intelligence, scientific research, and more its ability to handle parallel tasks efficiently in a cornerstone of modern computing. So which is helped in continuous innovation, will further expand the impact across industries. So will further driving innovation in various fields. So it is the main thing which I want to specify to all of you. It is about the conclusion which is given to me. The future of GPU programming in high performance and artificial intelligence are, first thing which we need to remember is X-scale computing. GPUs are a core part of systems, achieving high performance, supporting breakthroughs in weather prediction, drug discovery, and artificial intelligence modeling. And also dedicated GPUs are going to be present for performing the operations of AI accelerators for mixed precision computations. Integration of GPUs with CPUs in platforms like NVIDIA, DIA, Grace, Hopper, Superchips enables the workflows, democratizing AI. So it is the cloud-based GPU services which are going to be present for making the application more useful. So these are the things which I want to share to all of you. So now, as the part has been completed, I need to acknowledge, I would like to thank the management of BVC Institute of Technology and Science for their continuous support. And also I would like to thank the course coordinator, Dr. K. Srinivas Garu, Dr. Anurag Garu for their continued support and collaboration, and ensure that active participation by all the participants, as well as taking care of everything in the delivery of the content. And it is about me. So thank you. Thank you for giving this opportunity. Now I am going to ask 4 or 5 questions in the chat box. I request everyone to give the answers, to type the answers there.
Sir, good evening, sir.
So now I want to ask 4 or 5 questions, multiple choice questions, sir.
Okay, sir. Okay.
One minute. One minute, please. So I have been asked, I am going to ask the multiple choice questions here. Which I have been asked. It is the first question which have been asked. I request everyone to type the answer. What is the correct answer? What does CUDA stand for? A. Compute. Good answers. Answer has been given. Kavita Garu, Sunita Garu, wonderful. It is good answer. The answer is correct. Compute Unified Device Architecture. Now, second question. What is the limitation of GPU computing? Limitation I am asking. What is the limitation of GPU computing? A. High power consumption. B. Inability to perform parallel tasks. C. Complexity in programming. D. Lack of scalability. When you listen my class, Ramcharan garu correct answer andi. Complexity in program. Okay, good answers. Answers have been given correctly. Now this one, just I have given the languages, but which language have been used, I have not given the answer. Sorry, it is not C++. Once again, think of it. A. Sorry, wrong answer. Which GPU programming language is used widely in machine language? Machine learning frameworks. The answer is Python. And just I have given the language names, but I have not given which language have been used. Now which I have given this explanation part. What does OpenCL stands for? A. Open Compute Language. B. Optimized Compute Library. C. Open Common Language. D. Open Computing List. Ramcharan garu correct. Rupali correct. Rahul garu correct. Kavita garu correct. Pratyusha. Okay, good answer, Sunday. Thank you to one and half. Next one or two more questions are there. Now moving to the somewhat important concept which we have seen. One of the optimization technique for reducing the latency, memory latency, which GPU optimization technique focus on reducing memory latency? A. Memory collapsing. B. Data compression. Sorry, and D. Kernel fusion. D. Thread synchronization. Sorry, and please read the question and give the answer. No issue. Ramcharan garu tappu. Answer Sanjay Verma garu. It is correct. Memory collapsing. Now just the last thing which we have seen, it is one of the easiest one. We have studied operating system, so based on that I am giving this question. It is related to the memory concepts. The same which is going to be related. Memory system which is critical in GPU architecture. DRAM, dynamic random access memory, cache, hierarchical memory, shared memory, which is the appropriate choice. A. Wrong answer. Well tried, at least good. Answer is C. Hierarchical memory. Hierarchical memory. Now, why GPU has become heavily utilizing in the real-time application? On which category it is going to be used? That is the question which I am asking, dear participants. Which industry heavily utilizes GPUs for rendering? A. Medicine, B. Gaming, C. Genomics, D. Finance. Ramcharan garu, correct andi? Answer is B. Good. Rupali garu, Pratyusha, everyone good answers. So the last question which I want to give. It is related to the parallelism. And what is the advantage of thread level parallelism in GPUs? Answer B, correct. So we have seen different basic questions which are going to be obtained based on the PPT which I have explained. So some contemporary research problems which are going to be used for PhD, I am going to provide to you. At least you can get some idea how it is going to be done, on which area it is going to be done. These are the some of the areas where those who want to do on for PhD, the problem statement on GPU computing. For that, I have given some topics and some papers where they can use them and help for having those concepts to be whether it may be optimization, memory and integral energy query processing, or like that. We are having different types of papers which are going to be used. In memory and integral query processing is going to be used. In quantum computing, they are going to be used. In complex graph problems and K-like counting problems, they are going to be used. Data sets on sparse matrices and graphs on GPU challenges, load imbalancing, irregular memory access patterns, they are going to be used. So these are some of the areas where at present GPU computing is going to be having some research which makes the participants who are interested on working on GPU can work on it so that they can get some base paper. I am not saying that it is one of the base paper. At least you can have some identification on which area you can move on and on which domain you can move on which topic you can move on. So it is about me and it is about the presentation. Thank you for giving this opportunity. One by one, I will send as a file. Okay, definitely. Please wait.
Sir, thank you, sir. Thank you. And
Request of the participants, I am sending the such topics are the areas. I'm unable to send the file. Srinivaskar, I am sending file to you only.
sir,
Please share this file. Those who are interested, they can access it.
okay.
I have sent to your
WhatsApp, sir.
send a text file. I have been sent to your WhatsApp. Okay, and it is. That's all from me. Thank you for giving this opportunity, Srinivaskar.
Sir, thank you very much, sir. Thank you very much for your good session and good orientation about this assessment test. Tomorrow we have directly from ATAL website only, and request the research aspects also.
Okay, sir. Thank you.
Okay, sir. Thank you very much. And I think one question is there in chat box.
I have not seen it.
I will check, sir.
Single file I have sent like that only to you.
Yes, sir.
Single text file I have WhatsApp you, sir. So
Yes,
you
sir.
can send that file to them. You can
Okay,
place it in the.
The group I will share. Okay.
Yeah, sure, sure. Okay, and thank you. That's all from me. Can I leave, sir, now?
Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. And dear participants, please switch on your videos for just screenshot purpose, attending purpose. I request the participants switch on your videos. Layout one. Insert this. For our documentation purpose, please switch on your videos few seconds. You will get this snapshot. I think many are not available. Hmm? Okay, sir. Kiran, sir, please. Yes, sir. No problem. Yes, sir.
Okay, sir. Thank you. And
Okay, sir. Thank you, sir. Thank you very much for your kind presentation. Okay. I request Vijay Kumari madam to share feedback of this session. Sir? No, sir. Session 10.
Sir, switch it on, sir, camera.
Okay, sir. Right, sir. Okay, sir. Thank you very much. And tomorrow we have 3 sessions. From 2 o'clock onward, sessions will start. 2 to 3:30 and 3:30 to 5 and 5 to 6:30. Then 6:30 to 7:30 feedback. You have to give feedback on ATAL portal about overall 6 days HPC workshop. Then assessment will be there. Assessment is 20 basic questions. Just like pattern, our Kirans are shared to you. The basic pattern questions will be there, and 20 questions, 30 minutes time will be there. You have to complete that one. Then validatory function 7:30 to 8. So please convenient to be available for that validation function. By that time, we will take all the videos. Okay. Thank you, sir. Thank you very much. And feedback, sir. Okay, now we will
So
share
certificates will be available by which date?
Sir?
Certificates will be available by which date?
Immediately once you have completed feedback and attendance posting, we are parallelly we are posting the attendances. Once we complete assessment test, immediately certificates will be available. Once if you have 80% of attendance and 70% of marks, sir.
Fine, sir.
Assessment test immediately. There is no issue.
Thank you, sir.
I am sharing research topics shared by the Kiran sir in our WhatsApp group. If anyone is would like to read, please refer out.
Hello. I'm audible to you?
Okay, now feedback will be shared and the sufficient time will be given for today's feedback. If anyone is not given for first session, so can give. Thank you. Thank you for your support.
Hello, sir. I'm audible to you?
Audible, madam. Audible.
Yeah, yes. One question I want to ask, sir. In the WhatsApp group, I find there is a one feedback form
Okay.
in which the video we have to attach. Is it mandatory to fill?
Madam?
It is mandatory to fill?
It is not mandatory, but
Because first time I'm seeing that type of the feedback. That's why I'm
no,
asking.
no. It is not mandatory, but you have
Okay.
few video bytes are required. That's why I kept it. Okay. The
Okay.
interested
But then one
people
more thing,
can share video byte regarding
okay, one more
that
request, sir.
organization is the main. Yes, sir.
Is it
Tell me.
feasible for you to share the PPTs of the whole ATAL FDPs?
Sure, sir. Sure, madam. It is the part of ATAL FTP. We will share all the PPTs and
On register email ID?
register email ID. We will share Google Drive links. We will share to you after collecting all the resource persons PPTs
Oh.
and presentations also. Presentation recordings also we will share to you, madam.
Okay. Thank you so much, sir. Thank you.
Thank you, madam. Thank you. If anyone has any clarification, you can ask me regarding the ATAL FDP. Thank you, one and all. I am concluding this meeting.